In this video, what we're going to do is this is a little sort of exercise in linear algebra. So we have show that if A, our matrix A, capital A, is an n by n invertible matrix that satisfies this expression here, okay, a squared plus 5a, or a cubed plus 5a squared minus 2a equals 0, then this holds. The inverse of a is equal to 1/2 of a plus 5 times I, where that's the identity matrix. Okay, so far so good. Essentially, bit of calculus, bit of arithmetic. Now, these two rules, these are just sort of general rules of of basics of linear algebra, matrices, multiplication. So if we have a summation there, p plus c, a times b plus c is simply equal to ab plus ac. Okay. Just a sort of consequence of that, we might sort of work this in reverse. B times a plus c times a can be written as b plus c times a. Okay. Now, essentially what I'm going to do is there's some tricks involved. There's some logical progressions, and it's of what I have planned, but they're sort of based, that this is the rationale behind some of those logical progressions. So just to sort of spell it out exactly what we're doing in terms of the basics of it. Now, so this is the equation that we're asked to start with. Okay. Now, what I'm going to do is I'm going to isolate a. Okay. So what I'm going to do here is I'm going to take subtract minus or add 2a to both sides. You could just treat this as a sort of normal polynomial equation or whatever. So I have 2a, a cubed plus 5a squared is equal to 2a. So what I'm also going to do is I'm just going to sort of divide both sides by 2. Get rid of that 2 there. So now I have an expression of a, for a, and it is a equals 1/2 of a cubed plus 5a squared. Okay, so far so good. Now, what I'm also going to say is this. This is just a sort of general rule to do with matrices. I've just scrolled down there, and it is very important. I'll do this in red pen. A times a minus 1, a to the minus 1 times a is equal to a, is also equal to a times a to the minus 1, and that is equal to the identity matrix always. That's just a general rule of thumb. So what I'm going to sort of say here is this. I'm going to use the first variant there, and that's as follows. A to the minus 1 times a equals the identity matrix. Okay. But what we're going to do here is we're going to use this expression here as a. Just think that through for a second. We're going to replace a with 1/2 of a cubed plus 5a squared. Great. Okay, so let's do that. So a to the minus 1 times 1/2 of a cubed plus 5a squared. Now, where I sort of use a, I can this rule back here. I'll just sort of getting at it here. We can a or a minus 1, b can be a cubed, and c can be 5a squared. Okay, so that just works. We can just use very basic concepts like that here. And we can take out that constant term at the start. So what we have here is 1/2 times a to the minus 1 times a cubed plus 5 times a to the minus 1. We'll leave that 5 in there where it is for the time being, times a squared. Okay. And that is equal to I. Okay. So where does that leave us? Let's just tidy that up now. What we're sort of saying is 1/2 of a to the minus 1 times a cubed is a squared, plus a to the minus 1 times a squared is times 5 is 5a, that is equal to the identity matrix. Okay, so what does that mean though for us? Well, let's just remember that I is equal to a to the minus 1 times a. Okay, so our expression here is 1/2 of a squared, so that's a times a, let's just write it as that, plus 5 times a, and that, 5 times a is, I'm actually going to just, for the sake of clarity, just remark that I'm going to write this as 5 times I times a, and that is equal to a to the minus 1 times a. Okay, so essentially the a squared, I'm just writing it as a. 5a, I'm writing as 5a times I. And I'm writing as a squared, a equals a. Okay, so what I'm going to do here is I'm able to I can take out a out of this expression here altogether. So what I have is 1/2 times a plus 5i times a equals a to the minus 1 times a. Okay, that is just following the sorry, do you know what I'm going to do here? Just for to make it clear, I'm actually just going to write a as 5 times I times a. So I'm replacing a with I times a, just a little bit clearer as to what I'm doing. Essentially, just to be absolutely crystal clear, a times I is equal to I times a, but it just makes the ordering, so it didn't really matter, but it just makes the ordering absolutely crystal clear. Okay, so I'm taking out a out of both terms there and this term there. So what I'm going to do here at the end is to simply cancel out the a terms. Okay, so what I'm left with is 1/2 times a plus 5i equals a to the minus 1, and that's what we were asked to do. So that's this linear algebra exercise.